Imagine a world where managing diabetes doesn't involve daily finger pricks. That's the promise of a groundbreaking new technology developed at MIT, offering a non-invasive way to monitor blood glucose levels. This could revolutionize how millions of people with diabetes manage their condition. The team at MIT has harnessed the power of Raman spectroscopy, a technique that uses light to analyze the chemical makeup of tissues. By shining near-infrared or visible light onto the skin, they can gather information about the glucose levels within. They've created a device, currently about the size of a shoebox, that can measure blood glucose without the need for needles. In tests with a healthy volunteer, the results from their device were comparable to those obtained by traditional continuous glucose monitoring sensors that require an under-the-skin wire. While the initial device is too large to be worn, the researchers have already developed a wearable version, which is now undergoing a small clinical study. For years, the finger prick has been the standard, says John Woon-Kong, a research scientist at MIT and senior author of the study. But nobody wants to prick their finger every day, multiple times a day. Many diabetic patients undertest their blood glucose levels, which can lead to serious complications. If we can create a highly accurate, non-invasive glucose monitor, almost everyone with diabetes will benefit. The lead author of the study, published in the journal Analytical Chemistry, is MIT postdoc Ariana Bressi. The research also involved Peter So, director of the MIT Laser Biomedical Research Center, LBRC, along with researchers from Apollon Incorporated, a biotechnology company. But here's where it gets controversial. Currently, most people with diabetes rely on finger pricks or wearable monitors that insert a sensor under the skin. While wearable monitors provide continuous readings, they can cause skin irritation and need to be replaced frequently. The MIT team's goal is to create a more comfortable, user-friendly alternative. They've been exploring non-invasive sensors based on Raman spectroscopy. This method analyzes how light scatters when it interacts with molecules in the tissue, revealing the tissue's chemical composition. In 2010, the LBRC researchers showed they could indirectly estimate glucose levels by comparing Raman signals from interstitial fluid, the fluid around skin cells, with blood glucose measurements. And this is the part most people miss. More recently, the team made a breakthrough by directly measuring glucose Raman signals from the skin. The challenge was isolating the tiny glucose signal from the many other signals in the tissue. They found a way to filter out the unwanted signals by shining near-infrared light at a specific angle. Initially, the equipment was about the size of a desktop printer. The team has since shrunk the device by focusing on just 3 specific spectral regions in the Raman spectrum. This approach reduced the equipment needed, making the device more compact and cost-effective, roughly the size of a shoebox. By focusing on just 3 bands instead of the entire spectrum, we've saved space, time, and cost, explains Bressi. In a clinical study at the MIT Center for Clinical Translation Research, CCTR, the new device was tested on a healthy volunteer over 4 hours. The volunteer rested their arm on the device, and a near-infrared beam measured glucose levels through a small window. Each measurement took about 30 seconds, with readings taken every 5 minutes. The volunteer consumed glucose drinks to simulate changes in blood sugar. The Raman-based device showed accuracy similar to that of 2 commercially available invasive glucose monitors. Since then, the researchers have developed a smaller prototype, about the size of a cell phone, which they're testing as a wearable monitor. They plan a larger study next year involving people with diabetes. They're also working on making the device even smaller, potentially watch-sized, and ensuring it works accurately for people with different skin tones. What do you think? Could this technology be a game-changer for diabetes management? Do you foresee any challenges or limitations? Share your thoughts in the comments below. This research was funded by the National Institutes of Health, the Korean Technology and Information Promotion Agency for SMEs, and Apollon Inc.